Hey, Jonathan here at Colfax Math. Today I was going to go over a little bit of data that displays the data. I'm going to talk about different ways to display data from dot plots, bar graphs, Venn diagrams, histograms, and what a frequency distribution is. This is all taken from Core Connections in CPM Chapter 2. I'm doing this as a quick review before we go back to school in the fall. So I'm going to try and review 6th grade math, and specifically this video is going to be about displays of data. So let's start right here with a dot plot. Let's say I take a die, and I take a single die and I roll it, and it comes up either a 1, 2, 3, 4, 5, or 6. So those are my outcomes. My value that it could possibly be, that would be an X. So I'm going to actually create that as a number line. That X-axis we've worked with a lot. And there are a couple possibilities. I could either get a 1, or I could get a 2, a 3, a 4, a 5, or a 6. So X are the possible values. And the dot plot says I take this die and I roll it, how many times did I get that? And I could write that out as a frequency distribution. And I did that right here. So I rolled a die 20 times. And 5 of those times I got a 1. 4 of those times I got a 2. 2 of those times I got a 3. 4 of those times I got a 4. 3 of those times I got a 5. And then I rolled a 6 4 times. So the number of times I got something is called a frequency. If I add that up, that's the number of times I rolled the die. So 5 plus 4 is 9, 11, 15, 18, 22. So this value right here is the total number of times that I did that experiment, or that I threw that die, and it's usually referred to as N. It's a frequency, how often it occurs. And then these values are my X values. So X is the actual thing I'm getting, like how many 1s did I get? Well, I got 5 1s, so I could represent that with 5 little dots above there. So it's kind of a visual representation here saying I threw a die 22 times, and 5 of those times I got a 1. 4 of those times I got a 2. I threw that die 2 times, I got a 3. 4 times a 4. 3 times I got a 5, and 4 times I got a 6. So that's called a dot plot. It's kind of a visual representation. It's a number line. X is the value you could get, and the number of dots above it is how many times you got it. A bar graph is really very similar, but usually use bar graphs when you're talking about non-numeric things. So let's say I interview a class and I ask them their favorite color and I count their hands. When I say how many people's favorite color is blue, and 7 kids put their hands up, so I draw a bar 7 units high. Again, this would be the frequency, and this would be the X value, the actual value. Then I ask the next question, how many students have the favorite color of green? And only 5 kids raise their hand. So there are 5 kids whose favorite color are green. And then I ask how many kids' favorite color is yellow? Never heard anybody with favorite color yellow. Let's say that's 4. So yellow, there are 4 students whose favorite color is yellow. And then I say purple, and 12 students raise their hand. And this one right here, purple, is 12 high. So again, this would be the frequency, how often it occurs. This is X, or the value. Usually when it's not a number or a numeric value, you use a bar graph like this. If I want to figure out the total number of students in the class who actually voted, I would add up the 4 plus 5, 9, plus 7, 16, plus 12, and I would get a total of 28. So there would be a total of 28. students in the class, and that would be my n value, or the number of people in the population. So this idea of the actual value and how often it occurs is a frequency distribution. So before I talk a little more about that, let me just mention Venn diagrams. Let's say I interview all the students in my class and I ask how many have cats, how many people only have cats, and 8 kids raise their hand. That's the number of people who only have cats. How many people have dogs? 6 students say they only have dogs. And then how many people have cats and dogs? Well, let's say 10 people have cats and dogs. So that would be, this is cats, and this is dogs. And then how many people have neither a cat nor dog in their classroom? And let's say 7 people say that. So this is a Venn diagram. It shows an intersection of 2 sets. So how many people in the class have cats? 8 plus 2, 10 have cats. However, how many people only have cats would be 8. How many people have dogs in the class? 8 students would say they have dogs. 2 of those students have cats and dogs. How many people in the class only have dogs? That would be 6. And then how many people in the class do not have a cat or a dog? That would be 7. So a Venn diagram uses these circles. They overlap by the number of people who are in both categories. So that's a Venn diagram there. Okay. And then just one other way to display data I'll just go over is really a frequency distribution. And that's kind of where I started as well. So this right here with the dice getting rolled, that's really a frequency distribution. X is the actual value. I take that die and I throw it and I roll it. I could get a 1, 2, 3, 4, 5, 6. It's a 6-sided die. I do that 22 times. And of those 22 times, 2 of those times I rolled a 3. It's kind of a random experiment. But the important thing to note here is that X is the actual value you get, and frequency is how often it occurs. I could draw a histogram, and what's common in a histogram is that these are windows of values. There's still going to be my horizontal axis X, but if I roll a die 22 times, how many times did I get between a 0 and say a 2? Well, that happened 9 times, so I'm going to put a 9 there. How many times did I get between above a 2 to a 4? So that's going to be the 3 and the 4. The 3 I got 2, the 4 I got 6, so this would be 6 times. How many times did I get between a 4 and a 6? Above 4 and a 6, so that would be a 5 and a 6, which would be 3 plus 4 is 7. And that's a histogram. So this is a 6, this right here would be a 7. Not that accurate, but I think you get the idea. My vertical axis here, my y-axis, y is the frequency, how often it occurred. My horizontal axis, x, is the value I'm talking about. And these are just 4 separate ways to display data. Kind of depends on what you're trying to say and what kind of data you're looking at. But this is also the foundation for statistics. So it's a really important idea to get down the basic ideas down, different ways to display it. And maybe the biggest idea is this idea of a frequency distribution, where x is the value you're looking at and y is the number of times it occurs. So, you know, I guess you could do your house or your neighborhood or your community, your city, your state, your country. But let's say you wanted to look at the average age of people. You could create a histogram by collecting all of that data. You might want to know, let's say in your city, how many people are between 0 and 10 years old. And maybe there's 3,000. How many people are between 10 and 20 years old? Maybe there's 4,000 between 20 and 30 years old. Maybe there's 5,000. and then how many people are between 30 and 40, and so on that way. So it's a great way to figure out the overall size of the population and how that age is distributed through that population. Again, that's called a histogram. A Venn diagram is where the circles overlap and you have sets overlapping. A bar graph is usually used when there's not numeric data, and a dot plot is kind of a visual representation of how often something occurs. So this is Colfax Math, just talking about displays of data from Chapter 2 in Course 1 of the CPM book. And hopefully that's a little bit of a refresher. Watch the video, do a few problems, and think about these ideas before you go back to school in the fall so you're ready to go. Thank you for watching.